down. We're going to take notes down. So the quiz coming up is going to have simplifying radicals like cube roots, fourth roots, fifth roots, that kind of thing. It's also going to have some fraction exponents that you need to simplify. That's stuff we did last week. And then it's also going to include solving radical equations. So like we did on Thursday last week, no, Friday, where we had x and we did inverse operations to get the variable by itself, and it was like x to the fifth, and so we needed to do a fifth root, something like that, inverse operations. And then the other thing that will be on the quiz is this, rationalizing the denominator. So rationalizing the denominator is taking a fraction with an irrational number in the denominator, multiplying it by a number that looks like 1, and then simplifying that fraction. Okay? This first page is going to kind of be set up. Like, here are the things that you need to know to do the thing. And then the second page of my notes is going to be, here's each step with a bunch of examples of what we're actually doing. Okay? So, rationalizing the denominator, we're going to take fractions that look like these. Why is my dog barking? She doesn't do that. That's really weird. Anyway, we're going to take fractions that look like these and turn them into fractions that look like this. Okay, so we have integers in the denominator. See the difference here? We've got 3, 8, 7, 5. This one has a radical in it, but that's fine. It's on top. Okay, our answers are going to look something like this sometimes, most of the time. But the bottom number here, the key is integer not in a square root, integers in square roots. And we're gonna be doing exclusively square roots with these. Exclusively square roots. What is happening? It's really weird. Okay. So this is going to require a thing called a conjugate. And in blue here is what it looks like in general, with some letters, some variables. We are going to turn that into numbers in just a second. So I'll have a numerical example. But conjugates are the same values. So it's going to look the same, except we're changing the sign. So we've done conjugates before, actually, when we multiply binomials. They look like this. Actually, I probably need to move that down. It's probably fine. Right about there. Okay, so for example, 2 plus the square root of 3. This is going to be a thing we have in a denominator. Okay. The conjugate, yeah, Sarah, I can slow down. I'm sorry. Got about here. Okay, the conjugate is the same values, just with a subtraction sign instead of a plus sign, or a plus sign instead of subtraction. Okay, so we're changing the sign and keeping all the values the same. Okay, so if we started with 2 plus the square root of 3, we're going to end with 2 minus the square root of 3. Or not end with, but this is the conjugate of the first thing. Okay, so the values are all the same. We just changed the sign in between them. Okay, we did this with binomials, and we're going to multiply these two numbers because that's why this is useful. This might seem like it's out of nowhere. Like, why are we doing this? We'll talk about why in a second. But when we multiply these, right, we would get x minus 2 times x plus 2, and we end up with x squared minus 4. x squared minus 4, right? The important thing about conjugates is when we multiply them, some stuff cancels out. The 2 times the 2 stays, and the square root of 3 times the square root of 3 stays. But the 2 times the square root of 3 and the square root of 3 times the 2, those are going to cancel out because we have positive and negative. That's what happens when you're a math teacher. Your aunt texts you math problems. It's like, why can't I figure this out? Okay, so same numbers, same values. It should look basically the same, except it's just the sign has changed. And not on both numbers, just in between them. Okay? Just in between them. So it's not negative 2 minus square root of 3. It's just 2 minus the square root of 3. All right? So, whoa. Now why? Why would we need this conjugate thing? What good does these two do? Well, because when we multiply them, we're not going to have a radical anymore. That's the important thing here. When we multiply these two things, the radical is going to go, it's just going to go away. It's going to go away. We still multiply everything in one parenthesis times everything in the other parenthesis. This was a common problem I saw yesterday when we were doing this, is the distribution aspect. But some stuff is going to cancel out so we can take a shortcut. And so remember, our goal is to get the radical out of the denominator. So when we multiply like this, the radical disappears, which means we won't have a radical in the denominator anymore. Denominator. Okay. So for example, if I do those same numbers, we're going to get 2 times 2 is 4. Square root of 3 times the square root of 3 is 3. That's the other important thing. These numbers are the same. So when we have a square root times a square root, if the numbers are the same, we just get what we started with, or what's inside. What we're saying is square root of 3 times square root of 3 is the square root of 9, which is just 3. So then 4 minus 3 is 1. This no longer has a radical in it. Now this has changed the value, right? We went from 2 plus the square root of 3 to 1. But when we're doing fractions, we'll multiply it by a fraction that looks like 1, and so the value isn't going to change. But this is why. This is why we're going to use these, because when we multiply something by its conjugate, the radical is going to go away. And so you can see here the distribution I did for this same problem. Okay, 2 in the square root of 3, 2 in the negative square root of 3, so it's these two binomials, and the stuff inside the box. Conveniently, this diagonal with the roots is always going to cancel out. And that is because we're using exactly the same numbers. We're just changing this side. Sorry, I don't know why I'm yawning so well. I know why I'm yawning so much. I'm tired. Okay. So these two things cancel out, and we're just left with the 4 and the -3. Okay. Another example just like this, where we're doing just the conjugate multiplication. We have 5 minus the square root of 3 and 5 plus the square root of 3. We're going to multiply these, but we can ignore, this is the only case where we can ignore the fact that you have to multiply the 5 times the square root of 3 and the square root of 3 times the 5. Right? When we're distributing, we have to multiply everything by each other, right? So the 5 times the 5, the square roots times the square roots, and the 5 times the square roots. But in this case, the 5 and the square root of 3 are going to cancel out here, right? And so you're going to get 5 times 5, 25. And then you're going to get the 3 times the 3, gives you 3, because they're square roots. And so you get 25 minus 3, 22. Okay, so we started with something with a square root, and we ended with an integer number. Okay, all right. So now we're going to actually use it to solve the problem, or to rationalize the denominator. We're actually going to use this, okay? And let me know if I'm going too fast or too slow. So the stuff on the side here, ignore till later. So you're going to get a problem that looks like this. Rationalize that fraction. Okay, we're not going to evaluate these. In most cases, our answer is actually going to look kind of like this. Like, look at this answer here. Okay, it's going to look kind of like that. So we don't have to worry about a complex answer. Our answer is going to look complex sometimes. These first few, I made up the numbers and they happen to simplify really well. So sometimes that happens, but on the quiz and the homework, they don't. Okay, they don't. So rationalize 3 divided by 1 plus the square root of 2. First step, find the conjugate of the bottom part. And you may need to pin my video if you can't see the whole thing. Okay, so find the conjugate. The conjugate is of the denominator, so the 1 plus the square root of 2. So the conjugate is going to be 1 minus the square root of 2. You just take the same numbers, change the sign in between. So sometimes this will be subtraction, and so your conjugate is going to be positive here. Okay, and then you're going to multiply the fraction, this original thing, by 1. We don't want to change its value. The value needs to stay the same. Value needs to stay the same, but we want the numbers to look different. So our goal is keep this value, whatever 3 divided by 1 plus the square root of 2 is. It's probably 0.9, 0.8, I don't know. And so we're multiplying our original fraction by the conjugate divided by the conjugate, right? If I simplify this Doesn't matter what these numbers are, they're exactly the same. So something divided by itself, this is just 1. So by multiplying this fraction by this, we're not changing the value. And you have to remember, fraction multiplication, you just multiply straight across. That's going to be 3 times this part, and this part times the bottom. Okay, so we multiply. I think I can move up to here. So we found the conjugate. We multiply our original fraction by the conjugate divided by itself. And then we just need to simplify. So here I reordered some stuff by distributing, right, the multiplication, and I reordered it a little bit. Doesn't really matter. You can do some of this in your head. This is not how I am actually going to solve the rest of the problems. I'm just laying out every single step. Okay. So now we got to simplify that fraction. We could just cancel here and then we'd be stuck with our original fraction. That doesn't get us anywhere. So we need to multiply this out. So we're going to do 3 times 1, 3 times the square root of 2, and then 1 times, and then this parenthesis times this parenthesis. And remember, because they're conjugates, we're going to have a bunch of pieces that cancel. So we're going to get 1 times 1 and square root of 2 times the square root of 2. So you get 3 times 1 is 3. 3 times square root of 2 is 3 root 2. And then we have 1 times 1, which is 1, and root 2 times root 2, which is 2. We get 1 minus 2. Simplify the bottom. And then we have a negative down here. This is technically correct. It's fine. But we want this to be as simple as possible. If we're dividing by 1, really this doesn't need to be a fraction anymore. So some of them sometimes will not end up as fractions, but often they're going to be. You make a problem, guess at numbers, and sometimes it doesn't work out how you want it to. So our original thing, 3 plus 1 over square root of 2, this is equivalent to negative 3 plus 3 root 2. This might look weird because we have a negative here, but remember, this is actually bigger than this. Square root of 2 is 1 point something. And so this is bigger than 1. So this number is bigger than 3, and it's bigger than this. So this gives you a tiny positive number. Okay, and that's it. So we multiply our original problem by the conjugate divided by the conjugate, and then we simplify that fraction. We may need to go, we'll see if we can finish all these examples in time. Okay, so we're gonna do 3 more of these. Oh, ignore this part. That's true. What I wrote is true, but it has nothing to do with what we're doing. So, original problem is this. 7 divided by 2 minus the square root of 5. Okay, this one also happened to simplify to be negative 1. I don't know why. I'm sorry. The next two won't. So the process is the same though. Okay, you're going to multiply and this is what me solving this problem actually looks like. I don't write out all those steps. You may need to, but we're looking for the conjugate divided by the conjugate, multiply straight across, distribute the top. This is important, right? The 7 is getting multiplied by 2 and the square root of 5. So the conjugate is, just switch the sign here. So we originally had 2 minus the square root of 5. Now we have 2 plus square root of 5. So we're going to distribute. 2 times 2 is 4. Square root of 5 times the square root of 5 is 5. And then the 7 needs to get multiplied by everything here. So 7 times 2 is 14. 7 times the square root of 5 is 7 square root of 5. And then we just got to simplify this bottom part. Get -1 turns into subtraction. This also looks weird because we have a negative number, but that's because the square root of 5 is bigger than 2, and so this was always negative. It just doesn't look negative to us. To the right, like this. Okay. 5 minutes to do 2 examples. Might be a little quick, but we'll see. These next 2 examples, the first one is going to look like homework problems. The next one's also going to look like homework problems. These are both like homework problems, except very rarely do we get 1 down here. And so it simplifies into not being a fraction anymore. Most of these are going to end up as a fraction answer. Okay. So you can just keep going on your paper. I ran out of space vertically, right? So here we are. Try to get my paper as far over that way as possible. So original problem in black here, 5 divided by 3 minus the square root of 6. This would be pretty typical. Okay. The conjugate of 3 minus the square root of 6 is 3 plus the square root of 6. So I'm going to multiply this by 3 plus the square root of 6 and 3 plus the square root of 6. So this doesn't change the value of the problem at all. 3 plus the square root of 6. Okay, if this was a plus here, then we'd use a minus for our conjugate. We're just picking the opposite sign. And now I need to distribute across, because we're doing fraction multiplication, so we just multiply straight across. It's like a half times a half is a quarter, right? 1 times 1 and 2 times 2. So we're going to do 5 times 3, 5 times the square root of 6, and then 3 times 3, and square root of 6 times the square root of 6. So we get this. I wrote this in parentheses and didn't do the distribution right away, but you could. So 5 times 3 is going to give us 15. 5 times the square root of 6 is going to give us 5 squared 6. And then 9 minus 6 is 3. I think I went a bit faster than that, but the key here is 2 things. Recognizing what the conjugate needs to be, and then fully multiplying. So yesterday I saw a lot of like, oh, you just get 15 root 6 plus 15 plus root 6. No. The 5 needs to multiply by the 3 and the root 6. And you distribute it to everything. And we're actually distributing here to everything. It's just that the 3 times the root 6, like these 2 things, cancel out perfectly, right? So then we're also doing, these 2 pieces don't cancel out. Okay, so 3 times 3 gives us the 9. Root 6 times root 6 is what the inside was originally, so it's just 6. So 9 minus 6 is 3. Okay, the homework, I'm going to do another example. The homework is like the last couple homeworks where it's like 8 problems from the book, but you only need to do the even one, so it's only 4. Okay, so that lets you look in the back if you need to look at the odd examples, odd problems. So this is an odd problem from the textbook problems. Let's ignore all this blue stuff so we can just focus on the problem. There's 2 radicals down here. Now, this is harder than what's going to be on the quiz. What's going to be on the quiz is like the last problem, this one over here. Okay, so this is slightly harder, but it's the same thing. Just because we have two radicals here, same process. We cannot add the square root of 3 and the square root of 7. That does not equal the square root of 10. Those are not the same thing. Not the same. Okay, so the conjugate is the same values, just switch this to subtraction. 3 minus square root of 7, 3 minus the square root of 7. Okay, and then we distribute. So 9 times both of these things. And then when we simplify this conjugate multiplication here, right, it's just square root of 3 times square root of 3, which is 3. Square root of 7 times square root of 7, which is 7. And so then it's just 3 minus 7. None of this is going to divide nicely. So this is a perfectly good answer, but we have a negative down here, so you could change it to switch the signs on the top and positive on the bottom. Either one of these is fine.